Hi, everyone. This is Cornell University's submission for the 2021 Design Build Fly competition with their aircraft titled the Carnelian Rocket. Here you can see images of our aircraft from three views. One of the main design features you'll see is that we have a long fuselage, and that's in order to facilitate our 18-inch long sensor. We determined early in the design process that sensor length was the most important attribute of the total score. And so you can also see here in one of our diagrams that we have a carbon fiber rod on the along the bottom of our fuselage, and that's consistent with a body on frame design philosophy that's often employed in other vehicles such as automobiles, and that's in order to improve the structural stability, especially on landing for our aircraft. Here you can see dimensions of our aircraft as well as the total weights for each mission. The difference here being for mission 2, we're carrying our 4 containers. And for mission 3, we're just carrying the single sensor. We have our deployment mechanism installed for all 3 missions, so it's not removable. For control architecture, we went with a standard RC receiver, as well as standard servos for our control surfaces. For our LED controller, we use an off-the-shelf LED kit that is able to interface with our receiver. And for our propulsion system, we went with a single 5,000 milliamp hour 40C LiPo battery for our flight tests. And for our final configuration, we use 2 of those in parallel in order to attain the 10 minutes of flight time necessary for the competition. And here you can see an image of our motor in our aircraft. For sizing, we use a design space of power loading and wing loading, and that's able to couple the aerodynamic and propulsion characteristics of our aircraft to the total mass of the aircraft. And we place constraints on the maximum stall speed, the minimum cruise velocity, the maximum takeoff distance as set by the competition rules, as well as the maximum power attainable by a realistic propulsion system. You can see in the bottom right, this is the sum of the M2 and M3 score components. And here is the optimal design point that we went with for our power loading and wing loading. We also perform sizing on the number of containers, and there's obviously a direct relationship to the mission 2 score as seen in the scoring equation. There's also an indirect relationship on the M3 score because for a fixed total aircraft mass, as you increase the number of containers, you will ultimately be decreasing the empty weight of the aircraft. And here you can see for the total score, this was the optimal design point, which had 8 containers. So ultimately, we opted to go with fewer containers, so about 4, due to constraints in the design and manufacturing process. Here you can see images of our deployment mechanism and our sensor. So for the deployment mechanism, we have a large spool attached to a high torque servo. Here on the right side, there's a slip ring, which helps prevent rotation or twisting of the wires upon deployment and retraction. And here you can see in our sensor, we have our LED controller, as well as the LEDs here on this wood component in the back. And lastly, you can see here our mission performance estimates for all 3 missions, as well as our total score estimates. And here you can see our successful ground mission test, where we have our deployment and retraction of our sensor. We also did perform a simulated mission 1 test, where we had a successful takeoff, and on landing, we had a belly landing off the runway. Unfortunately, the footage for that was corrupted, so we don't have that to present to you today. We also did perform another flight, or we attempted another flight test with our sensor, so a mission 2, mission 3 simulated test. However, that ultimately did not have a successful takeoff, so we don't have footage to present to that either today. We'd lastly like to acknowledge the hard work placed by all the members on our team in spite of the COVID-19 pandemic. So despite all the challenges people have faced, we're proud of the aircraft we've been able to produce, and we're grateful for the opportunity to present to you all in the competition this year.